Guys, welcome back to episode 3 of Python for Complete Beginners. In the last class, I talked about data types and variable. Today, I'm going to do a deeper dive into strings, talk about the attribute of strings, and I'm also going to introduce you to lists and also talk about the attributes of lists. So let's get started. Alright, just a quick reminder, these are the 3 functions we've used so far. Now remember, there are a lot of functions in Python, a lot. You don't need to cram them, just know how to use these functions, and then whenever it's time for you to need to use them, rather, you can just find a way to Google them or something. As a matter of fact, we'll be doing some Googling today. So, like I said, we want to do a deep dive into these data types and understand the attributes and attributes they have. Now, when I talk about attributes of an object, right? So when we talk about attributes of an object, now remember, everything in Python is an object, right? A data type can be referred to as a particular object that belongs to a particular data type is also an object. So I'm talking about a lot of things actually. So the attributes includes things like the methods of the object class. Now I'm going to explain this. I'm also referring to the kind of operations it supports, the kind of operations it supports. Now remember, in the last class I showed you what happens whenever you try to use the addition operator on 2 strings, or you get a concatenation, right? And I showed you that when you try to multiply 2 strings, you get error. That's because of each of these data types or each of these objects have different attributes and different behaviors to different operators. So when we talk about the attribute of an object, we're also referring to the kind of operations it supports and how it behaves to a particular operator. So for now, these are the 2 things, right? So let's start with string or strings. So I'm going to create strings. I'm going to create a string. Let's just call it a string location. I'm going to set the string to, let's say, Nigeria. So just for confirmation's sake, I can go ahead and print location, and I get Nigeria. Now quickly, I'm going to open a tab here, and I'm going to type Python string attributes. Now, one thing I try as much as possible to do when I'm teaching is to let people know that it is very, very okay as a programmer to go online and search for results or search for solution. It is something that even happens in the professional world, right? So, of course, it is different from the academic setting where you have to cram everything to your head and the rest. But in the real world, if you're a programmer, a lot of programmers go online to search for results or solutions when they are stuck, right? So I think, like I said, I think what is really, really important when it comes to programming is creativity. You have to know how to be creative with these things, not about cramming the functions and the methods and stuff like that. So, like I said, feel free to go online to search for solutions or search for a method or search for a function. Now, I'm going to tell you what a method is quickly. Let's open Python string method. Now, before we go into this, what are methods? Now, methods are similar to functions. So just like we have the print function, the input function, and the type function, right? Methods are actually similar to those things. The difference between a method and a function is that a method is specific to a class of objects. A method is specific to a class of objects, so the method is only available through that object. I'm going to explain that shortly. When we call functions, we can call function at any time, at any point in time, and use them and pass the right argument to them and then use. But for method, they have to be called through an object. Now, what I mean is this. Now, if you type Python string attributes on Google, you're going to see something like Python string method, right? and we have several methods here. You can see that these methods, they apply like, they look like function, right? They have the function name and then the bracket that function have, right? But the thing is that all these methods are only applicable to strings. That's why I said methods are specific to objects. So what do I mean? Let's take this first one for instance. Now the first one says capitalize, and what does this method do? What this method does is that it converts the first character to uppercase. So let's go back to this guy here, and then we know that in this string here, all our letters are in small cases, right? So if I say location, if I say print location, well, let's do this way to make it easier. I'm going to say location underscore 2 equal to the original location dot capitalize, and then I'm going to just do this. Now let's go back here. I'm taking this capitalize from this guy here, so it's not something strange. Now if I run this and then decide to print out location 2, you can see that I have the same copy of location, but this time around the first letter has been capitalized. Now you can see that this is called like a regular function, however it is called through location. It is like directly applied to location. So unlike calling a function where you just go ahead and just you know when you call a regular function where you just call a function and then pass in the brackets, right? But in this case you have to first indicate the object you want to apply the method to, right? Followed by a dot, then followed by the method. And if the method is a method that takes in arguments, you pass in the arguments here. But in this case, capitalize does not take any arguments. Now, just like we have in functions, we have methods that have return value, methods that take arguments, or regular methods that just execute themselves without returning any value. Right, so in this method, this particular method called capitalize has a return value, right? And the return value is a copy of the object attached to it, but this time around it capitalizes the first letter. That's very, very interesting. Now we can also do it this way: print location dot capitalize. Remember this. So you don't have to necessarily save it in a variable first. You can just directly print it out on the screen. So that's one of the methods that the class of string have. Now, just to explain how methods work in a better way, or to explain better, let's take another object and let's call this object age, and let this object be a float, right? Now let's try to print age dot capitalize. Get error. Now what does the error say? The error says that float object has no attributes capitalized. So it means that the capitalized attributes or the capitalized method belongs to only the class of strings. So float has its own attributes, strings have its own attributes, right? So but the capitalized attribute does not belong to the float attribute, it belongs to the string attribute. So now that we understand the concept of method, let's play around with other string methods. So we have caseful, we have center, we have count. Of course, you can always come here and check things yourself. We have expand tabs, we have find, we have formats, we have format map, we have index, we have its number, we have a lot of them. So you can read what these things are, but let me just show you some interesting one. And one thing that I use often, this find is a very interesting one. Let me show you what this find does. So find allows you to find a particular string or character in that string. So what I mean is this: if you come back here, let's say you have a statement, right? And the statement says I am a boy. Now let's save that. Now we can say boy equal to statement dot find. and here I'm going to pass an argument boy. Now I'm going to run this, and then I am going to print out boy. Now we have 7 as a result. Now what happened here? What has happened here is this. In this statement here, I am a boy. We are trying to find where the location of boy in this statement. Now if you start counting from the very first letter here, let's start counting, right? I here would be at location 0 because it's the very first letter or the first character, followed by a space. So the space here will be location 1, A here will be location 2, M location 3, the space here 4, the A here 5, the space here 6, and then the B here is 7. So that's why you have 7. So it's basically telling us the position of this string within this string. So this boy here is actually at position 7 if you start counting from 0 from the very first character. So it has found the boy and has told you where the position is. Now, one interesting thing about this might look strange, but let me just show you guys this. I can put this actually statement. Now that I know the position of boy, right, I can actually do statements, and then I can say 7 colon is, and I'm going to get boy. Now this might look strange, but this also talks about the attributes of strings. So one attribute of strings is that they can be indexed. What I mean by they can be indexed is that you can actually specify the index of a character within a string and then select that particular character. Now, to make this easier for you, I'm going to come back to this, but let's try something. I'm going to say print statement. Then notice that I have what we call a square bracket here. So what I want to do now is I want to index indexing a string. I call this indexing the string. So I want to index the string. Let's say I want to print this string, but I don't want to print all the characters in the string. I only want to print, let's say I only want to print I here, right? Because I is in position 0. Remember, when in programming you start counting from 0, right? So I is position 0. So if I put 0 here, I get I. Can you see? If I change this to 1, I'm going to get space. I'm going to get nothing actually, right? But actually there's something here, a space, and that's the space that is here because that space is at position 1. So if I decide to print out position 2, I'm going to get A. So let's try position 2, index 2, I'm going to get A. If I try index 3, can you guess what I'm going to get? Of course, I'm going to get M. If I try index 4, I'm going to get another space. If I try index 5, I'm going to get A. So basically the index is just the position of the character within the string. Index 0, index, and so on. Now that's what we mean by indexing. Now, but for instance, let's say I want to print not just one character. I want to print this arm here, right? Just this AN here. So I know that A is at index what? A is at index 2, right? So what I can do is I can say print 2 to 4. I'm going to get arm. So what do I mean? What have I done here? So index A is index 2, right? And index 4 is the space here, right? So I'm printing from 2 to 4. So you take everything starting from 2 to 3. So it's going to print 2 and 3. So this is going to print character 2. Let me say character at index 2 and 3. So what this means is if I try to print statements, let's say from 2 to 6, technically what I'm saying is print index 2 to 5. So whenever you do this thing, this is called slicing actually. This is called slicing. This is what we're trying to slice the statement by a particular portion, right? The string here. So it's trying to take a particular portion or a particular slice of the string. Here we are picking AM. Here we are picking 2 to 6. So that would be AM. So 2, 3, 4, 5, 6. So I'm picking AM space and A. Let's print this out. AM space and A. Alright, so what I've done here is slicing the string. So you can decide what particular character you want to print out. So this is another attribute that is kind of specific to string. You can't do this with integers, you can't do this with floats, you can only do this with string. So if you try to slice, for instance, let's say you have an integer that is let's say 1, 2, 3, 4, 5, and then you want to say A, you want to do print A slice, let's say you want to slice from 1 to 2, you get error. That's because int object is not subscriptable. So subscriptable means that you cannot use indexing for int object. Alright, let's talk about other attributes of string. We've seen indexing and slicing. And now one more thing about slicing. Now this here, yeah, you might see that I indicated the start index here, but I didn't indicate the last index, just like I did in this case, right? So technically, whenever you, let's have a different string. Let's look for a string, a simpler string somewhere around. Let's use string Samuel. Now, if I want to create a variable, I want to say this variable is name. I want to slice from, let's say I want to take just Sam. I want to take just Sam. So what I'm going to do is I can say from 0 to, this is S is 0, A is 1, M is 2, U is 3. So I'm going to say from 0 to 3. So I can go ahead now and then print A. So what I'm going to get is Sam, right? Now, whenever you are slicing from the beginning of the string, in this case I'm slicing from the very beginning of the string to somewhere around the middle of the string, you do not need to indicate the starting index. So what I'm trying to say is that pick everything from the beginning of the string up to the third index, right? So this will give us the same result as Sam, as you can see here. So whenever your index, your starting index is 0, there's no need to indicate it. Now, another thing is this. Let's say you want to print UEL, right? So you're starting from the middle of the string to the end of the string. So I can either do it this way, from 3 to the last part of the string will be, this is 4, 5, that will be 5. And if I run this and I decide to print B here, what I'm going to get is UEL. Okay, so it should be 6 actually. If I run this, I get UEL as expected. Now, because 6 happens to be the last letter in this string, so I'm printing from the middle to the end of the string, right? So I don't need to indicate 6. So automatically, when Python sees that you are not indicating the index where you want to stop, it just slides up to the end of the string. And whenever Python sees that you're not indicating the index you want to start from, it starts slicing from the beginning of the string. So if I do this, I do this, and I do this, I get the same result. Now, just for clarity's sake, whenever you're slicing, you have your start index and then you have your end index. Start index and end index. Now remember, if any of this is not indicated in the slicing, then Python assumes that you're slicing from the beginning or you're slicing to the end, depending on what you omit. Now, talking about index. Now, remember that I use the find function to find the position of boy. So whenever I use the find the find method rather, it tells me the position of the first letter in that argument, right? So because boy, technically the position of boy is going to be the position of B, because that's the first letter in boy. So this is just basically telling me the index of where B is. Now, talking about index, you can also find let me explain it this way. So if you come back to the string method there, you will see that there's a method called index that searches the string for a specified value and returns the position of where it was found. So this is basically the same thing as find. Can you see? So if you don't want to use the find function, you can also use the index function. So index method. I keep saying function, but this is actually a method, but it applies to only the class of string. So just to prove that index and find is the same thing, so let's change this here. So let's come back here. We have the statements here, and then let's use dot index. Oh, sorry, that's the wrong spelling of index. And then when you print out boy, we get the same result. So index and find is basically the same thing. All right, so let's go back to the methods for strings. We have a lot here. There's another one that is interesting that I love to. Okay, no, I don't want to go into that right now because that would mean that we have to talk about something else. I think we're going to stop there for now. So you can just go through this. Capitalize converts the first characters uppercase. Case food converts string into lowercase, so converts the whole string into lowercase. Center returns a centered string, right? Count returns the number of times a specific value occurs in a string. So let's use this count to round up methods for string, right? So looking at Samuel here, all the letters in Samuel appear only once. But let's create a string that has let's create a string that says let's just say AABB, right? So if you print name dot count and you decide to count A as the argument of this method, so we know that A appears twice. Let's make it appear 3 times. So this is going to give us 3. And if we change this to B, it's going to give us 2. So it's just basically counting the instance or the number of times that particular string given to it as an argument appears in the string here. So that's what the count method does. Remember, these are methods. They have to be applied directly to an object like this. So those are the methods of the class of string. Now, as time goes on, when I introduce more classes, more objects, I'm going to talk about their methods while I introduce them. So for now, I'm going to stop here on methods. And to round up this episode, I want to round this up with 2 new kinds of objects, or 2 new kinds of data types actually. So we have something called list and dictionary. List and dictionary. Now, what is a list and what is a dictionary? So list and dictionary is something. Remember, when you create a regular variable, for instance, let's say you have a name and the name is equal to Dan. Let's say you have another name, let's call this name 2, and the name is equal to James. Now you can only store one object in a variable, which is true, right? However, with data structures such as list and dictionary, you can actually store more than one object in a variable. What do I mean by this? Now, instead of having name and Dan and James saved in separate variable, I can actually have one variable holding both names. I don't mean through concatenation. What I mean is this: so I can have a variable called names, and then square brackets, I can have Dan inside, comma James. So what I've done here is I've just created a list. So this is what we call a list. So a list is basically a bunch of objects put together. And notice that I said objects. It's not just string. It could be string, it could be numbers, it could be any kind of object. A list can hold any kind of object. Even a list can even hold a function. We'll get to that in the advanced class, right? So a list allows you to hold several objects in one variable, right? Or as one object. Because the truth is this: if you decide to print out the type of names, right, the entire list is referred to as a single object, and this object belongs to the class of list. So if you print out type, you see this is class list. So it means that names is a list. So this is seen as a single object, right? But this object carries two other objects inside of it, which are two strings. As a matter of fact, let me add a number. So I'm going to add 55. So it carries two strings and an integer object, but all together they're referred to as a list, as a single object. Now if I decide to print out names, you might be kind of curious to what will happen. I'm going to get the entire list: Dan, James, and 55. Now let's say you want to print out the first name inside the list. Just like we did with indexing or slicing with string, you can also apply the same method to a list. So what I mean is this: I can actually print out names and decide to print out the name at index 0. Now this is going to print out Dan for me. If I run this, I can print out names and then index by 1. This is going to print out James. And of course, if I index 2, I'm sure you are guessing 55. Now, just like with this slicing with strings, you can also slice with list also. I can decide to print out everything from the beginning to position 2. That will give me Dan and James. Or I can say everything from position 1 to the end of the list. That will give me James and 55, just like we did with strings. So it means that the class of lists, or an object that belongs to the class of lists, supports slicing and indexing just like strings. So to confirm that, we can come back to this page here and then go to Python list methods. So these are the methods that apply to lists. You can see that the methods are very few compared to string method. So we have the append method, we have the clear method, we have the copy method, the count, the extend, the index, just like the index, the same index that we had in strings. We have the pop, we have the remove, we have the reverse, we have the sort. So I'm going to go just through a few of these. As a matter of fact, I think we should go through almost everything. So let's start with the very first one, which is append. So we know that the entire list contains 3 values, right? So if I print out names, I'm going to get Dan, James, and 55. All right. Let's say I want to add a new value to this list. I can say names.append, and I can pass in a new name. Let's call this Kemi. Now if I run this and then decide to print out names, you can see that Kemi has been added to names. So that's what the append list does. The word append means to add something in front. So I'm appending Kemi to the front of the list, which will now be the last value of the list. So if I decide to print out names index, so this Dan is index 0, index 1, index 2, index 3, so be index 3, Kemi will be index 3. I'm going to get Kemi. Now, one more thing before we proceed to the method of list is you can actually use negative index to index a particular value in a list. What do I mean by negative index? So let me just show you a negative index. So this means indexing from the back, indexing from the back. Now, I'm going to print out names again. And one thing, if you're using positive index like we've been doing before, right? Dan is index 0, James is index 1, 55 is index 2, Kem is index 3. That's if we are counting from the front. But if we're counting from the back, Kem is 0, 55, Kem is 0, 55 is 1, James is 2, and then Dan is 3. However, when counting from the back or when indexing from the back, you can't actually use, you can't start, it doesn't start with 0, it starts with 1. So what I mean is this. So if let's say I want to index from the back, which is negative index, I can say names minus 1. So instead of 1, instead of 3, minus 1. This minus indicates that I want to start counting from the back, right? So Kem is going to be minus 1, 55 is going to be minus 2, James is going to be minus 3, and Dan is going to be minus 4. So let's confirm that. This will give me Kem. So if I change this to minus 4, I'm going to get Dan. So that's what I mean by negative index, right? Now note that the negative index will not start from minus 0 because technically there's no such thing as minus 0. So it doesn't make any sense, right? Mathematically, there's no such thing as minus 0. So you start indexing with minus 1 from the back. However, if you're indexing with positive index from the front, you have to start from 0, which should give us Dan also. Alright, so let's quickly touch a few more methods that belongs to the class of lists, and we'll end this class, and then we'll talk about dictionaries in the next class. Like I said, you can always come to this page here or just Google list method, string method, and then you can have all this. So we've seen the append. Clear removes all the elements from the list. So let's try that. Even though, okay, let's just try that. So let's see, names dot clear, and then when you print out names, now it's an empty list, right? Now there is extend, like extend. So extend allows you to add more values to the list. Now unlike append only allows you to add just one new value to the list. Extend allows you to add many values at the same time. So now that we know that our list is empty because we've used the clear method on it, let's add 5 values to it. So if let's add 5 values to it, and say names dot extend. Then what you have to do here is you need to pass in a list. The extend method takes in a list as the argument. So inside here, I'm going to have a list, and in this list, I'm going to say James, James 2, 4, 5, 8. Let's do it that way. So that's 5 values. So we've extended that list. So now let's print names. I want to get James 2, 5, and 6. You can keep extending. You understand? I can even decide to names dot extend. Let's extend with let's add Lagos, and let's add a float this time around. So let's add 4.5. So if you decide to print out names, you're going to get James 2568 Lagos 4.5. Now something even tricky. Now if I want to make this list have 2 of each of this value, I want to extend this list by the same list. What I mean with this, so I can say names dot extend. I can extend names by names. Remember that the extend method takes in a list, right? And names itself is a list. So if I do this and then I print out names, what I get is now the list has been extended by itself. So initially we had just James to this place. Now I've added that same list again. Now that's one way of doing this. Another way to extend a list is or to create like a duplicate of a list. This is only a duplicate anyway, it's just an extension of the list, right? So what I will show you is this. You can actually do something like names is equal to names. Let me create a new string, a new list rather. Let's just keep it simple for now. Let's So Dan and Sam, right? And then so that's a name. You can confirm this by printing out names, right? So what I want to do is this. I want to say names equal to names asterisk, which is multiplication. Print out names. So you can see that we have Dan Sam, just like we had here. So that's two ways of going about the same solution. You can either extend the original list by that list, or you just multiply the list by 2 to get, double of that list. All right, those are the attributes, or some of the attributes of method. So I'm going to round that up here, and in the next class we're going to talk about dictionaries. So remember, always feel free to go online and check all these methods yourself and play around with them. They're all the same concepts, right? You apply them directly to the objects. Some of them take arguments, some of them have return value, some of them don't. I might still go through some of this method in the next class, but these are things you can actually figure out yourself. Alright, thank you guys very much for watching today's episode of Python for Complete Beginners. I hope you've learned something, and remember, you need to practice. Don't just practice while watching this video, practice even after this video. That's how you get to become an expert in these things, right? The more you practice, the more familiar you get yourself with Python, and bigger projects you can actually take on yourself. Alright guys, thank you very much. Please like, share, subscribe if you've not, and I'll see you in the next episode. Thank you very much.